Hi ladies and gentlemen, this is Ms. Koken. We are going to revisit the prom question, but instead of looking at this from the perspective of a confidence interval, we're going to be running a hypothesis test. Let's just recap the setup. The student council at a large high school is wondering if juniors or seniors are more likely to attend prom. They take a random sample of 50 juniors and find that 28 are planning on attending prom. They select a random sample of 45 seniors and 29 are planning on attending. The question is, do the data provide convincing evidence that a higher proportion of seniors are going to prom than juniors? Use a 5% significance level. You may remember that our parameter is P1 minus P2, which is the true difference in proportions between juniors and seniors going to prom. The sample statistic, of course, is P1 hat minus P2 hat, but before we can find the difference in proportions, we need to actually have the individual proportion values. This is the same statistic that we used to build our confidence interval with last time. But because we are conducting a hypothesis test, we need some hypotheses, and that means we're going to have a null hypothesis of P1 minus P2 is equal to 0, meaning no difference between the two, and an alternative hypothesis of the proportion of juniors planning on attending prom is less than the proportion of seniors attending prom, sorry. Okay, in terms of the name of the procedure, this is going to be a two-sample z-test for difference in proportions, P1 minus P2. Next, we check conditions. We did this before, and so I'm going to go ahead and write those down. We've got our state done, we've got our plan done. The next part that we need to work on is the do. And the mean of the sampling distribution of the difference in proportions is mu sub P1 hat minus P2 hat. And if you remember from when we learned about random variables a while ago, we know that those are going to take on the population proportion values, and those are the ones that we've got in our null hypothesis. So it's going to be P1 minus P2 is equal to 0. Now, we need a standard deviation, so let's write down the formula for standard deviation of the difference in proportions. And we learned about this formula in the previous set of notes. It's that idea of combining random variables and finding the standard deviation of the combination. All right, so next we need a picture, and that means we're going to have our approximately normal distribution with a center of 0 and a standard deviation of 0.10. And when we run this hypothesis test, let's see, there's our center 0. We saw that the alternative hypothesis is less than 0, and so we're going to shade in on the left-hand side, and our sample value the difference was 0.08. So now we've got our sketch and shade done. Next comes the general formula, which is test statistic is equal to the statistic minus the parameter over the standard deviation. And now we need the specific formula. So remember, what we're going to be using is a z-test, a two-sample z-test. So it's going to be z is equal to P1 hat minus P2 hat minus P1 minus P2 over, and then we're going to have our P1 hat 1 minus P1 hat over n plus n1 P2 hat 1 minus P2 hat over n2, and we're going to have the square root of that. So this is our standard deviation formula. But we have made kind of a fundamental shift in our thinking when we're running a hypothesis test. So let's take a look at that in a minute. What we're going to do is we're just going to plug in real quick, and our P1 hat minus P2 hat is that negative 0.08 minus the P1 minus P2 is 0. That's what's in our null hypothesis. And that's going to be divided by the standard deviation that we calculated, which is 0.10. And this is going to give us negative 0.80 for our z value. Okay, and then remember what we would do next is find the p-value that goes along with that z test statistic. And we can use normal CDF for that. So the theory behind any of these hypothesis tests is that we always assume the null hypothesis is true. And if the null hypothesis is true, then there's no difference between the proportion of juniors that will plan on attend prom and the proportion of seniors that are planning on attending prom. And if there's no difference, then it doesn't make sense that we have two separate fractions or two separate proportions. So what we end up doing is we end up using a combined proportion. And we use the subscript c for combined. So let's figure out what p sub c hat should be. If juniors and seniors behave exactly the same way and we need a combined proportion, then what we're going to do is we're going to add the number that are planning on attending prom of both the juniors and the seniors, and we're going to divide by the sample size for each of them so that we can come up with a combined proportion, 57 over 95, which gives us a p sub c hat of 0.60. And what this means now is we're going to go back and use p sub c hat in the large counts condition and in our calculation for the standard deviation. So if we have N1, which is 50 times 0.6, that's going to give us 0.30. When we do 50 times 0.4, we end up with 20. And 45 times 0.6 is going to give us 27. And 45 times 0.4 is going to give us 18. All of those are still greater than 10, so we can still say the sampling distribution is approximately normal, but we need to replace these values in our standard deviation calculation. So instead of 0.56, we're going to have 0.6. We'll have 0.4 there, 0.6, and 0.4 there. So we'll recalculate all of that, and we will end up with a standard deviation of 0.101. When we plug into our specific formula, it's going to be with the C's instead of the 1's and the 2's. And then we end up with a slightly different value, again, because this gets replaced by 0.101. And that means our test statistic value will be negative 0.79 instead, and that will give you a slightly different p-value, and the p-value is going to end up being 2148. Okay, so with the p-value, remember we're able to make the conclusion, so let's go ahead and do our conclusion for this. The conclusion, remember, is always going to be in the same format. The first thing that we're going to do is compare the p-value with the alpha. Then we're either going to reject or fail to reject, and then we're going to make a statement about having or not having convincing evidence. Remember that you can phrase it in a few different ways, but this is one way to hit all of those three items. Because the p-value of 0.2148 is greater than alpha of 0.05, we fail to reject the null hypothesis H0. We do not have convincing evidence the higher proportion of seniors is planning on going to the prom. Now, one thing before we close this out, and that is the interpretation of the p-value. The idea of the p-value is, assuming the null hypothesis is true, the p-value is the probability of us getting a sample value of what we got, or more extreme, more in the tail. And so that's how we're going to write up this interpretation. Okay, so now that we've got that done, we are ready to move on to our box of important information. Let's take another look at that combined proportion. We know that P sub C hat is going to be equal to the two numbers that are the successes for the two different samples divided by the two sample sizes. And we are going to remember that we're going to use P sub C hat to check the large counts condition. When it comes to our normal curve that we use for our sketch and shade, we know we always define with the mean and the standard deviation. This time, the mean, which is P sub 1, mu sub P sub 1 hat minus P sub 2 hat, is actually P1 minus P2. And our standard deviation of P sub 1 hat minus P sub 2 hat comes from the calculation of the standard deviation using the combined proportion. Our test statistic is going to have the same formula that it's had all year. When it comes to the general formula, test statistic is equal to statistic minus parameter divided by standard deviation. And the specific formula is going to have all that detail in it, where we've got z equal to P1 hat minus P2 hat. That's the sample statistic minus the population parameter, P1 minus P2, divided by, and then we get this formula for standard deviation, which is going to use the combined proportions. Last of all in our box, let's put in both the interpretation of the p-value and the conclusion that we draw at the end of the hypothesis test. After this, of course, you've got your check for understanding. So what I'd like for you to do is read through the question carefully, do as much of it as you can. You're going to be doing a state plan, do conclude. Remember to highlight the important information as you read through the question. When you're ready to check your answer, turn the video back on and compare your answer to the answer that I post. And I'll see you back in a few minutes. Okay, so here is the fully worked out solution. Hopefully you didn't have any trouble with that. If you did, pay attention to some of the details, and when we get back together again, you can ask me about the specific questions that you have. All right, that's it for this lesson, and we move on to the next one. See you soon.